Question 7 asks us to solve this differential equation given the substitution y is equal to u minus 2x. So we're used to what we have to do now. We're going to try and eliminate one of the variables and change dy dx into du dx and then solve. Again, also, it's useful to note here that u is equal to y plus 2x. And if we look at our equation here and here, we have 2x plus y, or some multiple thereof. So we're not going to make y, just substitute blindly in for y, but instead we look at our equation and we see how we can best make our substitution. Regardless, we also need to know one other thing to substitute. We need to know what dy dx is. So if we just take this first one here and we differentiate it, what do we get? Well, we get dy dx is equal to the derivative of u with respect to x, du dx, minus differentiate 2x, which gives us 2. So that means that for this equation, what we actually have is du by dx minus 2 is equal to negative, and this here is 4u plus 1 over 2u plus 1. So this is good. What do we do now? Well, we make du dx the subject of the equation. So du dx is equal to negative 4u plus 1 over 2u plus 1 plus 2. But as with our previous example, 2 isn't particularly useful to us, so we get rid of that and we replace it with 2 times 2u plus 1 over 2u plus 1. So it's still 2, but now I can combine the fractions into one fraction. What do I get? I get minus 4u plus minus 1 plus 4u plus 2 all over 2u plus 1. So again, it's fairly easy from this to see what's going to happen. This will cancel, this will cancel, this and these two. 2 minus 1, well, that's going to give me 1 over 2u plus 1 is equal to du by dx. Well, we know what type of equation this is. This is our simple separable differential equation. So I move all of the u's to the left-hand side, anything with an x in it to the right-hand side. What do I get? I'm going to get 2u plus 1 du is equal to 1 dx. But of course this makes no sense on its own, so what we have to do is integrate both sides so that this equation makes sense. The integral of 2u plus 1 is u squared plus u. The integral of 1 with respect to x is x plus c. Now, again, we are not given the initial equation in terms of u and x, we're given it in terms of y and x. So we need to go and substitute back in. This gives us y plus 2x squared plus y plus 2x equals to x plus c. Or, if we want to change this around a little bit, we can say that this is y plus 2x squared plus x plus y is equal to a constant. And there we have it. That is the general solution. We do not have to come up with the particular solution this time because we're not given any initial values.